Okay, so we are going to look at going from position, velocity, and acceleration graphs and going in between the three of them and using one to develop the others, given some extra information. So this is your required homework question that looks at concept 2A in your concept list for chapter 2. And I have a position versus time, velocity versus time, acceleration versus time graph, and I'm starting out with information on the velocity versus time graph. So the question reads, for the following three graphs, draw the correct matching graphs for position and acceleration given velocity. Assume that the initial position of the object is positive. Properly label the graph. So first let's start with properly labeling the graph. So position versus time graph. Well, we know that position is given to us in meters, typically is our unit, standard unit, and time, of course, is seconds. For a position versus time given in meters to seconds, our velocity is going to be in meters per second, and of course our time is in seconds. And for a given velocity graph of meters per second, our acceleration graph is given in meters per second squared, and our time is in seconds. All right, so there we have our proper labels of the graphs. Now it tells us that the position of the person that we're representing here is positive. So if I look at my position versus time graph, my origin is represented by this dashed line in all three cases. And I know I have to start somewhere above the origin. It doesn't tell me where, but since positive is above the origin and negative is below the origin, I know I have to start somewhere above the origin, so I'll just pick a value. Okay, so there, my initial position of that object is positive, it's above the origin. Now I need to look at what the velocity graph is telling me. And it tells me two things right off the bat. First, the velocity values are all below the velocity zero line. If they're below that zero line, that means they're negative. If velocity values are negative, I'm moving to the left. So first of all, I'm going to be moving to the left in my position versus time graph. If I start positive, leftward motion means I'm heading towards the negative. So I know from the get-go that I'm not going to see any position values above this area because I have to be moving towards the left or in the negative direction. All right, that's the first thing to think about. The second is that my velocity is getting bigger and bigger and bigger and bigger. My negative value is getting larger and larger and larger as I move to the left. Okay, so if my velocity is getting bigger and bigger and bigger, then for every same increment of time, my position is going to be larger changed. So if I'm getting faster and faster, I'm going to get a bigger and bigger change in my position for that same amount of time. So how does that look on that position versus time graph? Well, in the first little chunk of time, I might move a little bit in position. In the second chunk, I might move a bit more. And in the third chunk, I might move a bit more. And in the fourth chunk, I might move it even a bit more. So I get this curved shape to my position versus time graph. All right. Going from velocity to acceleration, we know that the acceleration is we can do this a number of different ways. We know that the acceleration is the slope of the velocity graph. Well, my slope is negative, so I'm going to have an acceleration below that zero, and it's constant, so it's not changing. That's one way to think about it. Another way to think about it is that my velocity is getting faster and faster and faster, bigger and bigger and bigger. So my acceleration is a non-zero value. I am changing my velocity. And that value is getting bigger and bigger negatively at a steady rate. And so my velocity must be, my acceleration must be negative and at a steady rate. All right, good job.